Hi, for today's lesson, we'll continue to learn more about systems of differential equations. In particular, we'll be looking at real eigenvalues. So systems of differential equations are multifunction differential equations. Eigenvectors are vectors x in the same direction as x, and eigenvalues are the values of the vectors change in length. Eigenvectors and eigenvalues come from this definition, ax is equal to lambda x. These definitions will make more sense as you go through the problem, and you can see how these are used. So, for an example, we need to solve the system with initial conditions y0 is equal to 1, 0. So our system will be capital Y for this example. So we are given two differential equations, dx over dt is equal to x plus y, and dy over dt is equal to 10x plus 5y. These two differential equations form a system. So with this in mind, we can now form a system d capital Y over dt is equal to 1, 1, 10, 5, capital Y. Now this capital Y holds the x and y's. And so this capital Y is just the column vector x, y. And this is the coefficient matrix. So this coefficient right here is 1, and this coefficient is 1. This coefficient is 10, this coefficient is 5. So now we have our coefficient matrix, and we call it A. In order to find the eigenvalues, we have to use this definition. The determinant, that's what these lines are, of A minus lambda I is equal to 0. This I just means identity, and so all this means is that lambda is subtracted across the diagonal of the coefficient matrix. So we have 1 minus lambda, 1, 10, 5 minus lambda, the determinant of this is equal to 0. Here, lambda is subtracted across this diagonal. Now, in order to evaluate a 2 by 2 determinant, we take the product of this and subtract by the product of this diagonal. So we have 1 minus lambda times 5 minus lambda minus 1 times 10 is equal to 0. Distributing, we get 5 minus lambda minus 5 lambda plus lambda squared minus 10 is equal to 0. Now we have something commonly known as a characteristic equation. Lambda squared minus 6 lambda minus 5 is equal to 0. So now we need to use the quadratic equation to solve this. So when evaluating this using the quadratic equation, this coefficient here will be our A term, this coefficient will be our B term, and this coefficient will be our C term. So lambda is equal to negative times negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times negative 5 over 2 times 1. After working out this term, we get lambda is equal to 6 plus or minus square root of 56 over 2, which is equal to 6 plus or minus 2 times square root of 14 over 2, which is equal to 3 plus or minus square root of 14. When we solve, we actually get two eigenvalues because this is a plus or minus. So our two eigenvalues are lambda is equal to 3 plus the square root of 14, and lambda is equal to 3 minus the square root of 14. Now that we have our eigenvalues, we can now solve for our eigenvectors. So we're going to start with our first eigenvalue, lambda is equal to 3 plus the square root of 14. Here, we're going to subtract across the diagonal, lambda, 3 plus square root of 14 here and here. However, we need to include that these two equations are both equal to 0. That's why this line is here to denote that these two equations right here are equal to 0. So now we're going to work this out. So after subtracting these lambdas, we get negative 2 minus square root of 14, 1, 0, 10, 2 minus the square root of 14, and 0. Now we need to make this term right here 1. So negative 2 minus square root of 14 times 2 minus square root of 14 over 10 is equal to 1. This may be tricky at first, but when working out radicals like this, we want to eventually get this down to an integer. So now with this in mind, we're going to apply this here. We're going to get 1, 2 minus square root of 14 over 10, 0, 10, 2 minus square root of 14, and 0. Now we have this 1, we need to get rid of this right here, make it a 0. So we're going to multiply this row by negative 10 and apply it here. However, we find that this term also cancels out, so we get an all 0 row for the bottom row. And for our top row, we have 1, 2 minus square root of 14 over 10, and 0. Now that we have now we get two equations from this matrix. We get our first equation, x1 plus 2 minus the square root of 14 over 10, y1 is equal to 0. and y1 is equal to y1. The reason for this is because that is an all-zero row. So now x1 is also equal to, if you use this, -2 plus square root of 14 over 10y1. And because y1 is free, we can let y1 equal some value. So it just depends on how it scales. So y1, we're going to just let it equal to 10. This will just let x1 equal to -2 plus the square root of 14. And here we have our first eigenvector, -2 plus the square root of 14, 10. Now, for our next eigenvalue, we have lambda is equal to 3 minus the square root of 14. And very similar to the first one, we're going to subtract the eigenvalue, 3 minus square root of 14, across the diagonals, right here and right here. After subtracting, we get -2 plus the square root of 14, 1, 0, 10, 2 plus the square root of 14, and 0. We're going to multiply this one by 2 plus the square root of 14 over 10. It's very similar to this one, but this one's a negative and this one's a positive right here. So now that we have that, we get 1, 2 plus the square root of 14, 10, 0, 10, 2 plus the square root of 14, and 0. Very similar to this matrix, we're going to multiply this row by -10 and clear this bottom row out. However, our top is very, very similar. We have 1, 2 plus square root of 14, 10, 0, 0, 0, 0. So here we see that these two differ by a sign, and that makes sense because our eigenvalues also differ by a sign. So now we get x2 plus 2 plus the square root of 14 over 10, y2 is equal to 0. And then we also get y2 is equal to y2. X2 can be rewritten as -2 minus square root of 14, y2 over 10. Y2 is free, so we can let y2 equal a number. So we're going to just let y2 equal to 10. It'll cancel out the 10 right here. So, and then leaving us with x2 is equal to -2 minus square root of 14. So our next eigenvector is -2 minus square root of 14 and 10. So eigenvectors are just found by the coefficients that x2 and y2 are equal to. So now we have our eigenvalues and eigenvectors. We can form a general solution to the system of differential equations. So our general solution is capital Y, because that's our system. Y of t is equal to c1 e to the 3 plus square root of 14t times -2 plus square root of 1410 plus c2 e times 3 minus square root of 14t times -2 minus square root of 14 over 10. So here the eigenvalues and eigenvectors go together. So this is the C1 and C2, these are just constants and they will change based upon initial conditions. So now, using the initial conditions we're given, this 0 right here is to be applied to the independent variable. And here, that would be t. And then this is our 1, 0. So these correspond to the rows. So top row, initial value, the value right here is 1. And the bottom row is 0. So 1, 0 is equal to c1 e to the 0, because the 0 is right here, times the vector -2 plus the square root of 1410, plus c2 e to the 0 times -2 minus square root of 1410. So e to the 0 is just 1. Now we can turn this into a matrix and solve. Because that's just 1, we get -2 plus square root of 14 c1 minus 2 minus square root of 14 c2 is equal to 1, and 10 c1 plus 10 c2 is equal to 0. So now we're just going to take the constants and put it in our matrix. This will make it less confusing. So -2 plus square root of 14, 10, -2 minus square root of 14, 10, 0, 0. We can, so when doing matrices, we can also try to find the easiest way. So the easiest way, it may seem, will be just to divide this row by 10. That'll leave 1 and 1 here. So then we can switch these rows, so leaving with 1, 1, 0 on top, and -2 plus square root of 14 minus 2 minus square root of 14 and 0. Now we have 1 on top, we just multiply by the opposite of this, 2 minus square root of 14, so this cancels out. And then we have a term down here, -2 times the square root of 14. So our top row, after we multiply this row by 2 minus square root of 14 and add to this row, we get 1, 1, 0, 0, -2 times square root of 14, and 1. So now we want to make this term right here 1. So we're going to just divide by what this is. So negative 1 over 2 times square root of 14. So now we have 1, 1, 0, 0 at 1, negative 1 times square root of 14. So if we multiply this row by negative 1, add to this row, we have 1, 0, and 0, 1. And then our 1 over 2 times square root of 14, and negative 1 over 2 times square root of 14. So this one right here is our C1, and this right here is our C2. So C1 is equal to 1 over 2 times the square root of 14, and C2 is equal to negative 1 over 2 times the square root of 14. So now that we have our specific constants, we plug these back into our general solution and get our solution to our IVP. IVP just means initial value problem. These are initial values given, so that is why this is an IVP. So our solution to the IVP is y of t is equal to 1 over 2 times square root of 14 e times 3 plus square root of 14t times the eigenvector negative 2 plus square root of 14 over 10 minus 1 over 2 square root of 14 e times 3 to the minus square root of 14t times the eigenvector negative 2 minus square root of 14 over 10. So eigenvectors and eigenvalues are used to take systems of differential equations and solve them in terms of these exponential powers and associated vectors. So I hope this helped you in understanding how to solve systems of differential equations that have real eigenvalues, which are just standard numbers. So I hope this helped you, and thank you very much for watching.